TTL Computer 2. Today we're going to be looking at our control circuit, and we're going to be looking to simplify this again with the use of a GAL. And we're hoping to reduce our chip count to simplify our build on this card. And we're looking at the current state of our control card design in our digital simulation. And I'll just briefly go over some of the elements that we're looking to simplify. And in the center here, we have two NAND gates that's doing some decoding on the signals that are coming out of our control ROMs to generate the signals for the program counter out high and low, and program counter in high and low, and memory in high and low. So those are some decode circuits there. We also have a D latch that we're using to latch our instruction in and our tick counter reset signals. Then we have some additional logic down here that we would need to implement, that is generating the tick counter reset signal. So those are a little bit of additional logic there. And then we have also another chip here that's generating the instruction in signal. So we are going to look to simplify this design, and we're going to look to replace this chip, this NAND chip, this latch, and this other NAND chip, as well as this logic. It's going to simplify that down and put all that into a GAL. And we are hoping to go to this design, and zoom in on this a little bit. So here is one of our NAND chips. We are going to still require that, and this is going to generate the signals for the memory in high and low. But we've replaced all those other chips with the single GAL chip. So we still have our tick counter and our instruction register, but now the GAL is going to be generating all of those signals. It's going to be generating the program counter in high and low, and the program counter out high and low, as well as the instruction register in signal, and the tick counter reset signal. So this is our GAL chip that we're going to be implementing. And let's just open this up and take a look at that design. Okay, so this is our logical build for our GAL, and we can see that we have four main elements in the GAL. We have the first our two D flip-flops that are the latches for the instruction register in signal and our tick counter reset signal. And these are D flip-flops, and those need to be flip-flops need to be clocked, and those will be clocked off of our P clock. And then our next element in our GAL is our tick counter reset circuit. And this is a straight copy from what we had in our control simulation. The next is the instruction register in signal, and that takes the instruction register signal from the latch, and that just ANDs that with our U clock to get our instruction register clock signal. And then our last section is the program counter logic, where we generate our program counter out high and program counter out low, and program counter in high and program counter in low signals. And then this here is just the equations from programming the GAL, and we can see that we have our tick counter reset equation, our instruction register clock equation, as well as our counter out high and low and counter in high and low equations. So these are all, again, designed to replicate what we're going to implement in our GAL. Okay, And again, so that's our gal chip, and we can take a look at that in our digital simulation. So we have that all built, and we can run this to verify this, and that is running. Okay. And we can see that our regression test program is running. Now, this is just a screenshot of testing the program gal in our testing jig. And this is just a copy of the image that I posted to the community pages. But I did in fact go through and do that second round of testing, a little bit more formalized testing, and the chip tested out okay. But then I saw something odd, really odd, and this uh, switch setting one is the not clear signal, corresponds to the not clear signal, which is is our reset signal on our computer. And when I was bringing this low, it was generating the clear signal as it should. But then when I put this back to high, it was relatching in the instruction register input, and the tick counter reset signals were being latched in again, and I just couldn't understand what was going on there. Just completely shouldn't have been happening, because the 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 clock signal for the latches is the P clock, which is here. Has nothing to do with this, with the not clear signal. So I didn't know what was going on. I was getting really concerned that the gal programming was not correct, and I was pretty confident that the code that I wrote for that was correct. So it would have been an error in the assembler. But yeah, so I was really banging my head against the wall as to what that might be. But then I I I realized that the clear signal is adjacent to the clock signal on the chip and in the breadboard. And you can see that some of these wires are not sitting like perfectly perpendicular in the breadboard. So I was just wondering, if could it possibly be some signal, a bleed over from the from the clear signal into the clock signal. So what I did was I moved these wires. I moved, one of them to be on the outside edge of the breadboard, and I moved the other one on the inside edge of the breadboard. And I did the testing again, and that cleared up the situation. So it looks like it was just a signal bleed over uh, from the breadboard, basically an issue in the breadboard signals. But yeah, a little frustrating, but I'm thinking that was the issue, because again, that clock signal is not the clock signal on the D latches in the gal is not really a configurable element. That's like a hardwired element in the chip. So I couldn't see how that signal, the clear signal, was affecting the clock, but other than that signal bleed over in the breadboards, which apparently is what it was. So yeah, so this is a good test. So I think that we've validated the gal build, in our simulation. We're running a good simulation, and I think that we've validated the gal in our testing jig as well. Okay, so this is giving me the go ahead to start the control card schematic build out, and then ultimately the PCB build out. Those will be my next activities. So until next time, that's it for today, and thanks for watching.